Welcome, my dear student, to this new topic that is addressing IO devices. Actually, in the last video, we also discussed that accessing IO devices in short. Here in this video, again, we try to cover the accessing IO devices part in details. Like the IO devices is connected to the bus using an IO interface circuit, which has an address decoder, which has a control circuit, and a status register also. Here, that all the certain things will be shown in graphical representations or the block diagram. This address decoder which decode the address placed on the address lines, thus enabling the device to recognize its address. The data register hold the data being transferred to or from the processor. The status register that hold the information which is necessary for the operation of the IO devices, and the data and status register are to be connected to the data lines and have the unique address of that one. This IO devices circuit coordinates with the IO transfer. Here we can observe these in the graphical representations. The many processor having which are used as the memory map IO, and some of the alternative approach which are used for handling net IO operations. Some processor have special instructions will be we I already discussed with you. Like Intel processor have the special input output instructions which has a separate 16-bit address space also for the IO devices. But IO devices can be also be connected to the processor in a memory map fashion also. In normally in a Power PC, the IO devices can be placed in a in the same address space as the memory or in a separate address space. Although the Power PC does not have any a special input-output instruction, it has to be a special control register also. Here we can observe the graphical representation. In that graphical representation, we observe that there are the four different lines are to be used. One line is for address, another line is for data, and another line is for the control. And that lines are to be connected with address decoder with a certain parts of the control circuits. Also, it is connected with the data and a status register. And this complete part will be again connected with the input device. Now, if you go in the first block, that is the address decoder, in that this address decoder which enables the device which are to be recognized its address when it appears on the address line, and the address decoder the data and a status register and a control circuitry which required to be a coordinate with the IO transfer which constitute the device interface circuits. After that, the control circuit. The next and important part is the control circuit. As its name indicate that it is the control circuit, it means that it will performing some certain control operation or that overall operation whatever to be performed in the complete internal part of the circuitry. Then after that, data and the status register. If you goes in a detail of the data and status register, in the that data register hold the data which is to be performed which is to be transferred to the processor from an input device or a received data from the processor for transfer and output device. The status register contains the information which is relevant to the operation of the IO devices. Such a register are also connected to the data bus and assign some unique address for that. These IO devices operate at a speed vastly with a different from that the processor. For example, when a human operator enters the character at keyboard, the processor can execute the millions of the instructions between the successive character entries. Because of that, we must ensure that the instruction to be read a character from a keyboard executed only when character is available in the input buffer of the keyboard interface. We must also ensure that the input character is read only once, not a repeat. To review the basic concept, we have to consider some examples of the input-output operation, which involving the keyboard and which involving also the video display of the computer system. The three register have to be there in that status register, that data register, and another is a control register also. There is data register also, which perform different tasks and different operations. And the last and important block is the input device. That the main function of that input device is to provide a certain parts of inputs, which are used for to providing the input to the for to performing a certain task. Recall that the rate of transfer to an IO to and from IO devices is slower than that the speed of the processor, and this creates the need of the mechanism to synchronize the data transfer between them. For that purpose, the program control IO is to be given, and the program control IO is the processor which is repeatedly monitor the status flag to achieve the necessary synchronization. The processor pulls the input output devices also. The two other mechanisms which are used to synchronize the transfer between the processor and memory, and that two different mechanism. By using that, you can synchronize the data between processor and memory, and the two methods are to be the interrupt method and another is the direct memory access method. And because of that, we have to study that interrupt method also, and as well as direct memory access method also in this video. Okay, so this is all about accessing the IO devices. How we can access the IO devices? It means that we can access the IO devices by IO map, IO also, by using certain instructions like in and out also, and by using memory map IO we can also access the different IO devices. For that purpose, we have to perform certain mechanism, we have to do a certain arrangement, and in that way we can access the different IO devices. So this is all about the accessing IO devices. Thank you.